Hi YouTube and welcome to my channel. So we'll be looking at this question where we have to find the area of a region enclosed by two curves. Now for a question like this, it simply means that on a plane there are two curves. Let's say the first one goes from here to here and the second curve goes this way. So the area enclosed by the two curves would be this space right here. We also know that integration helps us to calculate the area beneath a curve. So we are going to be using integration to find the area beneath this curve and the area above this curve at this points of intersection. So with when we have a question like this, the first thing we are going to do is to find the area of intersection. And to find the area of intersection, the first thing we do is we're going to equate the both curves or the both expressions. But then for this question, you notice that the first curve is in terms of x and the second curve is in terms of y. So we want to rewrite the both expressions so that they are in the same terms. So we can start with this. We have that x is equals minus y squared plus 4. And for this we have y is equals half x minus half. And if I'm going to rewrite this in terms of y, this means that y plus half is equals half x. And this also means that if I multiply every term here by 2, I'm certainly going to have 2y plus 1, which is equals x. Let me write this. So it means that my second expression would be this. So y plus 1 equals x. So the next thing we are going to do is to equate the two expressions for x, just so that we can get the points of intersection. So equating the two expressions, we have, let's say, 2y plus 1 is equals minus y squared plus 4. And this can be rewritten as, if this goes over to here, you have y squared plus 2y minus 4 plus 1 equals 0. And this is exactly the same thing as y squared plus 2y minus 3 equals 0. Now, using our factorization method, we know that we should multiply the value of the constant with the value of the coefficient of the first term, and we would find the factor of that product whose sum is the value in the middle term. That is minus 3 times coefficient of this is 1, which is minus 3. So what are the factors of minus 3 whose sum is plus 2? That should be 3 times minus 1. So it means this can be written as y squared plus 3y minus y minus 3. So we then factor out. If we factor out at this point, we have y plus 3, and here minus 1 is a factor, so we have y plus 3. So we are going to collect like terms together, and at this point we will have, from here we will have y minus 1 multiplied by y plus 3 equals 0. So this means that y is either equals 1 or equals minus 3. So y equals 1 or minus 3 would be our intersection point. So we are going to be using this intersection point to find integration. So, but before that, we want to write our integration in such a way that we won't have negative numbers. We have this, we had minus 3 and 1, and minus 3 is the smaller number, so we would have it at the lower bound and 1. So before that, since these are intersection points or boundary points is in y, we are going to substitute 0 for y in these expressions to find which expression would actually be bigger. And whatever expression we find to be numerically larger than the other one when y is 0 would be the first expression we write here. So for that, we have minus y squared plus 4. So minus y squared plus 4 when y is 0 would be 4. And 2y plus 1 when y is 0 would be 1. So this is numerically larger. So we have minus y squared plus 4 in brackets minus 2y plus 1 in brackets dy, because all these are in terms of y. So at this point we can start integrating. So for our integration, we have to integrate this. We have this would be equals minus y 2 plus 1 over 2 plus 1 plus 4y minus 2y 1 plus 1 over 1 plus 1 minus times plus would be minus y, and everything is supposed to be from the value of 1 to the value of minus 3. So that would give us minus y raised to the power 3 over 3 plus 4y minus 2y square over 2, of which when this cancels you have y square minus y from 1 to minus 3. So we're going to have to simplify this. First off, I see a common term, plus 4y and minus y. Plus 4y minus y will give us 3y. So I can as well just rewrite this as 3y. So I have 3y. So we are going to resolve this. So for this expression where y is 1, I have minus 1 raised to the power 3 over 3 plus 3 times 1 minus 1 raised to the power 2 minus where y now is minus 3, you have minus 3 raised to the power 3 over 3 plus 3 times minus 3 minus 3 raised to the power 2. So this would be 1 raised to the power 3 is 1, so that's minus 1 over 3 plus 3 minus 1, and this would be minus 3 raised to the power 3, that's minus 27 plus 27, so you have minus 27 over 3 minus times this minus this is minus 9, so we can say plus 9, and minus 3 raised to the power 2, that's 9, minus 9 times this, that's 9. So what would this give us? You have 9 plus 9, 18. 27 divided by 3, that's 9. Okay, minus 9, this goes. So now I have 9, this minus this, that's these two are out. So you have 3 minus 2, that's 3 minus 1, that's 2, plus 2 minus 1 over 3. So that's 9 plus 2, that's 11. 11 minus 1 over 3, that's 10 whole number 2 over 3, which is the same thing as 32 over 3. So the area of the region enclosed by the curve would be 32 over 3. So this is our answer, 32 over 3, or 10 whole number 2 over 3. So I hope you liked this video. If you liked this video, tap on the like button, subscribe, share with your friends, and see you on the next video.